And we continue from the place where we stopped at. It's practical class, no, and it's practical class number 2. Then, I mean, counting the records in order we understand where we are. But I should say that in our understanding, one practical class equal to 4 hours. And these 4 hours in our laboratory classes, practical classes, first you have some explanation of lecturer, of practical instructor, and next you have time to fulfill the task, and next you have time to considering of course amount of students. It's not possible in one whole class. Usually we work with groups individually. Each group has individual practical class, and then we have time to check what students did and to grade it. How we organize it in this way, not sure, but let's see. Right now our task is to continue our travel, our journey in airplane, not even history. It's in airplane design and its variant. Here we once again we see the Tupolev airplane. We have seen Lancaster airplane. Geometry was practically practically the same, but it doesn't mean that it's stolen from one or another design bureau. It's just similar features, similar general appearance of airplane. It's explained by similar ways designer go, and why they go with similar way, because we follow to some principles the shape of airplane. You understand already, I hope you already understand it very well, that it's determined by the aerodynamical properties, let's say, of airplane, that supersonic airplanes looks like, subsonic airplanes looks like, depending on what is the range of speed. Even in subsonic area they have different shapes. uh, Depending on their speed, we have different so-called specific load to the elements of structure, and as a result we have different shapes inside for the airplane. Different shapes, but not much different structure inside. Longitudinal elements for the wing spar, for the fuselage, more typical stringers actually scheme, as no, semi monocoque scheme, which consists of their skin supported with frames and stringers, rather than scheme supported with longerons. Uh, and for the wing, we may need the longeron scheme, SPA. In English, it's called SPA. SPA scheme, which is practically without stringers at all, or it has insufficient stringers. The torsion box scheme, which has rather massive SPA, but stringers has appeared, and stringers also significant already in their cross sections, and so-called integral or monoblock wing, where stringers and caps of spars, they are practically of the same cross section, practically equal in their areas, and this is more typical for high loads, for high speeds and for high loads, specific loads to the wing. Specific, it means a ratio of load with respect to the area of wing. No, I may understand that it's rather difficult to operate with such volume of information if you really are not familiar with it before, but maybe you already have some information before, because you are not really first year students, as we understand. And one more thing I got when I switched off the record. I said, gentlemen, I need to stop. I trust there are not only gentlemen. I mean, there are ladies either. So, ladies and gentlemen, let's continue. Class number 2 for practical training, for practical skills gaining, let it be. And we continue. Z1, monoplane, low plane or middle plane. Pay attention. Here it's visible that it's middle plane, mid plane, and we not see it right now in the photo, of course, but spar goes through the structure of the fuselage, and they meet compulsory. They like looking to each other. Uh, Maybe there is some short center wing inside. Maybe it's even more complex scheme, like spars goes through some area of the wing. Somewhere here they locking, and somewhere here they goes straight directly in order to shorten the way, let's say. What the short way it's necessary for, of course it's yet difficult for first years to understand, but we will try to understand it a little bit later. And thinking that you already know mechanics of material, I think you're able to get this idea, or even you're already familiar with it. Once again, strategic bomber, and it's supersonic strategic bomber, like Lancaster also. And this strategic bomber has 4 engines, where intake holes are. Look, under the wing, intake holes. Now, of course, for even for transonic airplanes, it will be a retractable landing gear. It's not visible here. We might see it somewhere here in another photos. And the most important feature of this airplane, no, I didn't say it's conventional scheme of aerodynamics. It's balancing scheme conventional. It means that stabilizer is after the wing. It has fin stabilizer that is by the word visible. It's so-called mid stabilizer. So it's in the middle of fin. The only fin mid stabilizer, monoplane, cantilever. What in other words you might use? Certainly, as I already said you, certainly supersonic. It's visible that it has 4 engines with nozzles after the wing, and intakes are under the wings, and they are of rectangular shape. Swept, but this geometry is variable. It's variable sweeptness. In photos, we see that it's maybe with almost straight wing on the takeoff near the ground, and we see that it's like with folded wings in the flight position, you see, when it's in supersonic speed. And very beautiful, but actually dreadful airplanes by their purpose. And what did I meant to say? Beside, okay, I forget something. Strategic bomber. Pay attention, elongation of the wing. Look what it's more similar to this airplane, this tiny child for gliding, you see. It's more similar to by their proportions, or to Cessna airplanes that we have seen, like business jet, that one or that one. And how it corresponds to my explanation that supersonic speed better to use compact shapes and so on, and elongation of this wing, and it's typical for strategic bomber, really much greater than elongation. Wing aspect ratio should be said correctly in English. Wing aspect ratio here is less, here is greater. Yes, and it's typical for strategic bombers. They have a rather long wing. It's determined by their necessity to fly long, because they are long-ranged airplanes. How do they work? I'm afraid already everyone understands. They spend in flight almost dozen of hours. They are going to some shooting position, let's say, where they shooting missiles and coming back. They are not going to the directly to the place where they're going to shoot, where they're going to drop these bombs or missiles or something like this. They are called strategic bombers, but mostly they are working with missiles. And they goes far from the airfield they are based on, but not completely close to the place where they need to hit. So they have a range of operating very long. They purpose it for long travels, for long flights. That is why they need good aerodynamical characteristics. Uh, in contrary to front bombers that more interested in maneuverable characteristic, and in this case they are more short-winged, and they are not so aerodynamically perfect, but they should be quick in rotations. Strategic bombers usually good flyers, and I should also say that the very first generation of jet passenger airplanes of Tupolev family, they actually appeared from bombers. The very first airplane 104 to 104, the very first. It was like reconstruction of strategic bomber of that period, and it was redesigned, and it became the very first passenger jet aircraft in the world. So they are good flyers just because they are long-ranged airplanes. What I have noticed, be ready to see something extremely weird. Oh my, what is it? No, not much extremely. You will see more weird things today. Uh, this one, oh, I forgot to see the time, to notice the time. Sorry, make a note for myself because it's appeared at the time complete disaster in this meaning. Not able to remember the time. No, first of all, what is it? Monoplane, certainly, it's monoplane. But what a funny thing, look, it has canard scheme. It's visible for you. The stabilizer is on the top. In contrary to military airplanes, look, you do remember what I have shown to you? Here is stabiliator. Yes, canard scheme, but there are no elevators. Stabiliator. And in this one, what do we see? We see elevators. We see quite normal stabilizer with elevators. We see landing gear of three-leg, typical with nose wheel, three-leg scheme. How sweet. You see, in contrary to our Antonov 140, it's hide the main landing gear legs with wheels immediately in the wing. And it's not the weirdest place where we may hide the landing gear. No, in some cases, it's not visible. In some airplanes, in these airplanes, it's visible. What about their speed? Speed range. What do we see here? We see props. If we see props, what we might say, certainly, no, in this case, it's visible even for me, certainly that it's not piston engine, it comes about turboprops. And here you see the props which are behind the engine. It's so-called pushing scheme. It's also quite normal decision. And let's come back to the photo of Wright brother airplane. What scheme is used here? The same pushing scheme. Prop is behind of the airplane. So it's typical since beginning of aviation age, you see. Uh, Very funny general appearance of this airplane. Certainly, it's a sort of business jet. I trust. Look, but not speedy one. And better, of course, in this case, to check business jet or just some experimental plane. You see windows. It means some team of either passenger or scientist should be inside and have access to outer surrounding environment to watch. Fin, look, fin, it's not really a fin. Where it has fins, it's even difficult to say whether they are fins or tips, wing tips on the end of the wing for increasing the lift abilities for reducing the drag and reducing this harmful effect. Will not jump again with photos. I hope you do remember, like vortices that form compulsory on the end of the wing, and question is only whether they will be greater or less, these vortices. And in order to reduce these vortices appearing and their significance, their size, we have winglets or wingtips deviated to the top, or maybe even deviated to the top to the bottom to prevent motion of bottom air to the higher surfaces, to the upper surfaces. And here is not winglet, I think. I think they are fins, you might see, because they are greater in areas than necessary for winglets, especially for this tiny airplane. So it has double fin, twin fin, but it's placed not on the fuselage, as you might see. It's placed on the tips of the wing. The wing itself is constant geometry. It's not changeable in the it's not changeable in flight, but what we will, might see that it has non-regular geometry. Sweepness near the root is greater, and sweepness on the closer to the ends of the half of wing, you see it's practically straight wing. And one more additional piece of fin here is, and directed to another side. Why it's directed to another side? Because props are too close. I trust it's because of problem with downwashing the control surfaces here. In case it will be directed up. That was the reason why they use fins at the tips of the wing instead of placing its hair. Because in this case, downwashing of the fin, which should be of course greater than twin fins, this halves of fin, it will be much greater in size, but downwashing will be downwashing of control surfaces, especially important. Not the fin itself, but downwashing of control surfaces will be wrong. Let's say will be not convenient for flight and for controlling. What do we see right now? We see not real airplanes, I should say. We see so-called concepts, conceptual pictures. Yesterday, when we've been talking about the process of design, I said you that when it's necessary, like to answer to the need of society or to the some ministry or some company order, first it's developed some different concepts, and this concept may be completely different in general appearance, meaning to correspond to the same flight performances, actually, even. And what do you see here? No, maybe not ideally visible this thing in this photo, because but top two photos is one concept and bottom is another concept. It's concept of company, Boeing company, where they permanently have competition. This USA and the European companies, they permanently have competition. Who is greater? Who is the king, let's say. And Airbus and Boeing permanently compete for catching the market, for catching the different segments of the market. And traditionally it was Boeing like over winning with their Boeing 747 of different modifications since 60 years of previous century when it was created, first manufactured. They changed it sometimes already, even design was changed. Visually, like external sizes, external shapes, practically the same, but really it's already at least in half another airplane. I'm not talking about engines different already. I'm talking about inner structures different, made of another materials, more modern, more perfect, more weight effective, and so on. And when it's appeared at last, Airbus came into market with their A380, it's appeared that Airbus now greater than American companies with their airplanes. And Boeing been on the way to prepare their response airplane for more people than for 7 or for 800 people for traveling between megapolises, of course. And what they did, you see, they have proposed a concept rather similar to the Airbus, two passenger decks, conventional scheme, monoplane, cantilever, conventional scheme, quite traditional scheme, and it's very similar to the Airbus actually. Let me to jump at all. Until we've been talking, but here is Airbus. Until not been talking, until I made a pause, I prepared the additional photos, just save it in this file. What? Look at this. That one been here before and for another purposes. Look, it's Airbus airplane. You see what is the difference? We will see what is the difference, I hope. Practical is the same. Conventional scheme, low wing, this dihedral wing, so call it, vertical stability, vertical roll. It's in this surface, in this axis, along longitudinal axis stability. It's against rolling of airplane. But for engines, you see, for engines along the wing, but certainly it's visible here. And normal, conventional aerodynamical scheme, here it's visible that it's low stabilizer, stabilizer with respect to the fin. Fin here it's visible, but stabilizer not visible. But in this photo, it's visible where stabilizer is with respect to the fin. It's under the fin on the fuselage, so it's low stabilizer, low wing, 4 engines, 2 flight decks for passengers, windows, illuminators visible. Luxury airplane and oi and look, if not not another amount of engines and sizes of engines, we might say, oh, Airbus. No, not Airbus. Airbus even less beautiful. I don't like Airbus planes. They are visually don't like. They are not beautiful. What really it was said by one of our designers, a very known, famous designer, the ugly air vehicle can't fly. In translation of from our language to English, what is ugly, it can't fly. And really, Airbus planes, by what pilots say, they are bad gliders. With respect to Soviet famous airplanes like Tupolev Ilyushin, or with respect to the Boeing airplanes, Airbus are worse gliders by their aerodynamical perfectness. They are worse than another airplanes, and they are less beautiful. I see relation here. Look, Boeing has prepared concept of conventional type at that moment, quite conventional, very similar to Airbus. Difference only that Airbus has cylindrical fuselage, practically cylinder, and that one it's oval-like. It's more pulled to the top, to the bottom, like oval, and like egg. And another concept was, I hope we will see it in another photos later. It's visible. No, you understand. It's Photoshop, or like now we would say artificial intelligence. At that time, they were also developed artificial intelligence capabilities, and you see the airplane, which practically does not exist in the front view, because it's huge in the top view. It's a huge flying wing, and this huge flying wing, it's has everything, including all the passenger decks inside of this wing, and it has the engines, 4 engines there in the concept on the rear edge of the swing, and so on. The concept itself was very beautiful, and there are videos with flying models, scaled, of course, models, very interesting videos. Everything is great, but Boeing was about to stop on conventional scheme. Why? No, if this is so great, so aerodynamically perfect, so beautiful at all, why on this? Because it's necessary to produce it. And in manufacturing, this conventional scheme will be more simple, more easy, and cheaper as a result. Manufacturability will be better, cheaper than this flying wing scheme. And whatever beautiful designer may draw, next manufacturer says, okay, do produce it on your own. If you're so clever, if you so like it, that such design, do it. So designers, aerodynamics, they are also always limited with demands of manufacturing, not only by demands of market, but demands of manufacturing. Let's continue our travel. Oh, disaster. What is it? What is it? Easy to understand. We see right now the front of it and the rear of it. Uh, Front, what it looks like, it's a boat. Yes, it's one of the ancient variants, not ancient, of course, you understand. I mean, old, rather old variants of flying boats, easy distinguishable by this type of fuselage, by these floats. Say me, please, is it landing gear like this? Certainly not. It comes about some special support. It's you see, it's aviation museum. It's just on the airfield. And what we might see here, no, those supports, typical fuselage. And what is interesting? What is interesting in this wing? Gull wing. In this case, there is no problem with cockpit. Why again gull wing? Uh, they just been striving to move engine as far from water as possible, as high from water as possible. And that is why wing it's like broken in shoulders, you see. On one hand, wing need, as I'm already said it, like two halves need to meet each other in order to close bending moment to each other. And here is the need on one hand to place the center wing somewhere. They may do it over the fuselage, but maybe traditions of their design and traditions of their manufacturers also like through the top, not over the fuselage, but through the top of the fuselage, center wing is hidden inside the fuselage. Again, it's maybe done for the purposes of improving the downwashing of fuselage in the flight. It's maybe done because of demands of compactness of airplane as a whole. But whatsoever they made decision to have this wing of gull shape, it's BRF airplane and it's old one. And this beautiful place, how do you think it's peaceful airplane if it has gun machine on board? Certainly not. Maybe it's military airplane and it has, not maybe, but yes, it's military airplane and this place, it's like additional cockpit at the end. You know, such decision in American airplanes were very popular, especially in their strategic bombers of that time, of Second World War. And in our bombers, it was similar things. When at the end of the fuselage, completely separate cockpit, they are not even corresponding in flight with the cockpit where pilots are. And this cockpit is only for shooter, for the gun machine, and for the one who controlling this gun machine. In case they have problem, if someone trying to engage them, air engage, or someone try, or they notice, no, if this airplane for patrolling the sea area, the territory which you need to control, let's say, which is your territory, and you don't like to have enemies there. Of course, this one, it's a military airplane with weapon ready to shoot. And it was BREF 6 and rather old. And here is BREF 12. And what do we see? It's comparatively new. It's already also not in service, as far as I know. Some of them yet flying, but it's already not in service. It's also sea patrolling against submarines, against some ships undesirable in your territory, and practically very similar to this BREF 6 by schemes and some design features. Not different. If you start watching different photos, you'll see they are different, but very similar, extremely similar. Nose is different. Here not ideally visible, but visible. Nose is different, after fuselage is different, but fuselage and wing in general, they are similar. And here is, no, you might see stabilizer of, it's higher than fuselage, but it's it can't be said that it's high stabilizer. It's higher than fuselage, yes, but fin is not visible on this photo. What piece of fin is visible? You see, fin joined by middle of its surface to the stabilizer, and here it's also may be notable, and and here it's perfectly visible that fin is approximately in the middle, twin fin on sides, and approximately at the middle of the mm, it's the middle of the stabilizer itself. And what else? No, engines of props type. Here is maybe piston engines, maybe already turboprop. It's necessary to see uh, it's turboprop. It's turboprop engine. Don't ask me how I see it. I see it somehow. By intakes, by some another features, I may propose it's turboprop. But you may check my words. You see the name of the plane, so it's easy to check me. And let's continue. Look at this ugly photo. Actually, very beautiful airplane as a whole. It's beautiful, and this airplane also we will see it by its proportion. What is it? And this airplane, it's the sort of flying. Not that one. In this variant, it has, look at this, like cross here, cruciform. Now it's normal conventional fin and stabilizer immediately in the same axis. It has fuselage wings are of jet type hidden in just simple turbojet engines hidden inside of the wing. They goes through the wing and exhaust will be behind of the wing. And look at this variant of this airplane. Notice it's yet the same scheme with two uh, engines with each wing and one fin. Look at this, it's real photo. It's the same airplane. It's Missishev Design Bureau, and in NATO classification, this airplane is called Bison. Look at it. Seems like it's strategic bomber. Yes, it might be used as strategic bomber, but it's one important distinguished feature we will see right now. I'll like take your attention to this in a minute. I hope I'll not forget. It's modification of it, and to pay attention that fin now is not in the middle, not much visible in this photo, but certainly we understand it's two surfaces, fin now divided on two surfaces, and they are on sides of stabilizer instead of variant where fin was in the middle and was of greater area. What is it for? No, in variant of strategic bomber, it's with conventional scheme of empennage, and in case it's used for carrying the heavy cargo, it was used for as cargo airplane for transporting the blocks of space rockets, for instance, for launching devices, transporting from the place where been produced. No, it's in Soviet Union we have place of launching rather far from the place of their manufacturing, and their huge pieces may be manufactured in different places. Uh, don't be surprised. Yeah, I trust you are not surprised. You of course heard about such variants of organizing of manufacturing, and later, in some lectures, we will also talk about this. That manufacturing may be distributed, let's say, in different territories, even in different countries, and like pieces of these pieces of airplanes are transported by another airplanes to the place of final assembly. You know this, I trust for Airbus company and their airplanes. You know it for Boeing, and certainly you know it for some European Fighters, for example, Typhoon fighters, they assembled all over Europe, and next they are transported by means of another airplanes, transported to the France, to the final assembly place. And the same situation was with our space devices and shuttle-like devices. Actually, this one was redesigned, as you might see, uh, from strategic bomber, good flyer, long-ranged monoplane, conventional scheme. Seems like everything is conventional. One moment is non-conventional, uh, but it was redesigned to transport cargo on the outer surface. And you also know at least one more airplane, very popular in China, was, I trust, I know that China mm, considered thought to restore manufacturing of Antonov 124 airplanes. It was some period ago at least, and I trust that airplanes An 124 Antonov Ruslan and 224 Antonov Mriya are literally translated like dream. Ruslan, it's a man name. It's out of our legend, of our fairy tales, let's say. And Mriya, it's Ukrainian word dream. And Mriya being designed originally, it's considered like hugest airplane in the world. No, now it's not exist. The only plane was destroyed in the at the air, not at the airfield, in the hangar, not far from Kiev, in second year, no, 22nd year. You understand why? And those airplanes, what this Missishev airplane, Maria, they were competitors somehow, and they been purposed for transporting of another airplanes or of heavy cargoes or um, pieces of space rockets on the outer surface, on shoulders, let's say. And also, they're quite able to carry cargoes, to accommodate cargoes inside, but uh, some loads, some cargoes, they are too much big in over, no, in oversize. No, overall sizes. Sorry, they are big in overall sizes. They can't be squeezed inside the fuselage, even the fuselage of the hugest airplane in the world. Yeah? But their weight is appropriate and not so sufficient as their overall sizes. And in this case, airplane may carry it like in outer supports, but for purposes of taking off and landing of an airplane itself, quite clear that airplane can't carry it under the belly. It may carry it only on the wing or on the fuselage from top. That you see right now, one decision. Maria was one more decision in this means, and now in America they have also their own carrier, or this airship carrier, airspace ship carrier, but it's yet under development, let's say. Well, but at least they have some different airplanes like Airbus Beluga. It's named after one of dolphins type, and Boeing 747 freight version, cargo version, which used for, especially used for transportation of pieces of another airplane to the place of assembly. Da, I forgot. What is this interesting feature that I said? Say me, what is the type of landing gear here? Is it three-legged landing gear we see, like we get used to? Nose wheel, two main legs, and what? No, it's a called bicycle landing gear. Let me to jump to the scheme. Hop. Look, landing gear may be with legs, traditionally with legs, three legs, three-legged or multiple-legged, and it may be let's leave it right now like this. No, you see it, center of gravity and legs. It's maybe with center of gravity closer to the main legs, and in this case, nose leg is no third leg is under the nose. It's more typical for modern airplane, which are empty, let's say, in this area. Not empty, of course, they have cockpit usually there. And under the cockpit, the portion of inner space may be spent for hiding the nose of landing gear. And moreover, such position of airplane, this horizontal position, it's more convenient for passengers, for crew, for whatsoever, for taking off. And even in military modern airplanes, this scheme of landing gear more usable. It's maybe three legs if airplane is not much heavy, and so-called multi-leg. These multi-legs, they are usually main legs multiplied. Some supports under the wing, under the fuselage might be like the whole carriage with wheels. It's typical for heavy airplanes, but anyway, they have nose wheel. And old version. Sorry, I need to reject the call. Так, is it okay? Everything yet. And I'm afraid it was some advertising or some cheaters, considering the number. Time to time it's happened. Even attempt to block the messenger may start with such a call. Let's come back to the story about landing gear. Look, here is typical for period, pioneer year of aviation, the period of Second World War. Typical decision of landing gear. Why? Because mostly engines being put here in the front fuselage, in the forward fuselage, it was completely taken with engine. There were no place where to hide landing gear. And that was the primary reason, let's say, to place one more support on the land here to the under the tail, let's say, at the aft fuselage. And additionally, this flight position, what this one, it was rather simple in technical meaning to keep the take off position convenient for taking off with increased angle of attack. It was convenient for start flight, but of course it's not convenient in case you have passenger airplane, but such deviated from horizontal position, because in cruise flight next it will be in normal horizontal position. And one more rather rare but exist, it's called bicycle. Look, do compare. Here is you have multiple landing gear, center of gravity, and nose leg and main legs. And here is bicycle one, two-wheel bicycle. And bicycle for children usually have two wheels and a couple both side wheels for supporting the child until child is not quite able to use a bicycle properly. And here is main landing gear with two legs, one under the nose, another somewhere under the fuselage, and two tiny wheels on sides here should be. It's one of the airplanes that we have already once seen. It's Yakovlev. What language is now Yak 25? And we have seen it already. Look at this. In increased photo, you see landing gear consists of nose wheel, one main wheel, and two little tiny landing gear wheels on sides. It's visible. In flight configuration, of course, not visible. In airfield, it's great visible. You see, under the wings, it has additional wheels support. And do pay attention to the same air. Oi, we jumped here. Let's jump back. I revealed all my secrets. Why? And what do you see here? Landing gear is unusual. No, I do not promise that it will be the same heart in your task, I think you will have no so significant features to notice, but do pay attention each time what is the type of landing gear. In the photo that you see, pay attention. It's maybe surprise. And here you see main landing gear under the nose, closer to the nose, main landing gear under the fuselage, here under the belly fuselage, and on sides, on the tips of wings practically, also legs of landing gear to support it during takeoff and landing on the ground. Like this. Next. No, here is the same, but in general appearance. And by its proportion, by its general appearance, what is it? Strategic bomber, of course. It's strategic bomber, and however it's beautiful, they are, of course, not peaceful airplanes. Next, we have one more airplane, also certainly military airplane, but in comparison to this one, look what it looks like. That one, conventional scheme aerodynamically. Wing swept, wing swept. So range of speeds approximately the same. Here is, look, wings inside, engines of jet type. Simple jet turbine engines, typical for military airplanes. For military airplanes, typical turbojet engine or turbojet with afterburning. No, it's already for fighters usually, something like this. Not even for front bombers, mostly for fighters. Attack airplanes, they subsonic, and fighters may be both subsonic and supersonic, depending on the conditions of this air engages, let's say, depending on what they are fight with. No, I hope you do remember that attack is attack airplane, attack helicopter. They are of air to ground class. They are working against the targets on the ground, enemy troops, tanks, some buildings, something like this. They are attacking something on the ground. Fighter is air-to-air airplane. No, they are engaging with another airplanes, not with targets on the ground. No, and bombing, you understand it without explanation. Whatever bomber is it. The only difference that strategic bombers, as I already said you, they goes far, like to another country, to another continent, but not close to this place of hitting and working by missiles. And from front bombers, they usually working immediately over the battlefield or over someone city. No, depends on. But they are more maneuverable airplanes, strategic bombers for long travels, better gliders, front bombers with more maneuverability, and they are not so extended in overall sizes. That is strategic bomber. That one, no, maybe not even a bomber at all. Maybe it's patrolling airplane. But what do might see? Oh, I think it's one of brief airplane actually, considering the position of engines. I think that I see floats here on sides. You understand, and I think it's. I didn't keep here the name of this airplane. I think it's patrolling or sea patrolling airplane or some another kind of patrolling airplane, because it has, and it's either amphibious or flying boat. What do I mean? Because engines, look, they are over the fuselage, not even in the, first of all, here's mid wing, so call it. You see, it passes through the middle of fuselage. It's no, it's obvious, it's visible everywhere. It's not high wing even. And in this case, you see high wing, even higher than fuselage. This canopy, or how to say it? No, not canopy. It's cooling of the wing spars are joined even higher than fuselage. They are not passing through the fuselage. No, for aircraft designer, it's obvious. And engines of jet type, likewise here, jet type, but here they are rather close to the surface of the airfield at the moment of takeoff. And this one, they are placed much higher than the surface of the airfield. That may be realized for cases of taking off from water, and also it's a typical decision for cargo and passenger airplanes which work on so-called unprepared, uncivilized airfields, on the ground airfields, in the polar area, in desert somewhere, where no good conditions of airfield. And in this case, in order to prevent any interference of surrounding things, let's say like snow, sand, and so on, in engine, uh, water, in case of flying boats, engines placed higher as possible, higher than the wing itself. In case it's possible they are placed over the wing and additionally may downwash the wing and increase lift. It's a typical decision for short takeoff and landing, stall, so-called airplanes. And if design of the wing in this case, or some other matters of inner design of airplane, like do not permit you to make such a decision, then over the pylons, over the fuselage on pylons, and in such a way that they do not reduce downwashing, they not spoil downwashing of the stabilizer here. And look what happened to stabilizer. In this case, jet stream of engines, it's somewhere in this, along this line, and if it creates some bad downwashing, no, like spoiling of downwashing, it will be under the stabilizer. So it's not affect the stabilizer. In this case, look what happened. Wing is not affected with engines, moreover, maybe even increasing the downwashing here, improving, because here the engine which suck air over the wing, like increase speed over the wing and increase lift due to this. And jet stream from these engines, it's grows, no, like it goes in these directions. If stabilizer of low type, of middle type will be, in this case, the elevators will be not effective, and they do not work properly due to jet stream downwashing, no, like spoiling the downwashing of them in different modes of flight. And that is why, look, this shape, why, what it determined with, that is why this stabilizer is of T type. It's on the tip of the fin, in order to have better downwashing. Especially it comes not even about the stabilizer itself, but about the elevators. Look at this. We have elevators on site. And what is also interesting in this photo in particular, that it's greatly visible what high lift devices it has. At this moment, it has no fuller flap, certainly, because it looks like it's increased the area of the wing in this moment. What do compare? Ailerons at the place, what both left aileron, right aileron, they are not deviated, no? And area of wing, chord of the wing in this place, and practically what just after the aileron, it looks like increased, because it's a multi-sectional folder flap which move far from the wing and increase the area. Well, who is next? Who is next? Next is, once again, strategic bomber. This is already, again, Soviet strategic bomber, Tupolev Tu-95. And that is I place it on purpose here. That is in our relation to landing gear and how to hide landing gear in particular. No, besides of its strategic bomber, it has appropriate proportions. Let's characterize it by the word. Давайте. Let's do it together. Monoplane, cantilever, high wing. You see, a wing is practically on the top of the fuselage. High wing, landing gear seems like normal landing gear, 3 wheels, 2 main legs, 1 nose leg, 4 engines of turboprop type. It means that it's limited with the range of motion. Do pay attention, by the way, to these places of what. Uh, when you see such opening at the end, let's say, of the engine, it's certainly, I hope you do remember what I explained, is that in such type of engine, around 70%, from 70 to 90 even, 70%, like 2/3 and little bit more, let it be 3/4, okay? 3/4 of thrust created by props, and another portion it's created by jet stream yet. Here is visible the nozzle, and this nozzle is immediately under the wing, you see, practically under the wing. And to pay attention, look at this engine, what's it? What the barrel is on the rear portion of the wing here. Until you are thinking about, we continue. Think, please, what this may be for, and take a look onto this photo together to start thinking properly. I hope you already understood what is the secret. Will not pull time more. Reveal this secret. This is the nestle, it's called in English, gondola, nestle, for hiding the landing gear in flight, for retracting the landing gear. You see what a weird decision seems like, but it's not weird. It's not the only airplane with such design decision of the retracting of landing gear. For some reason, they need this landing, because this airplane. Why they didn't place landing gear somewhere closer to the fuselage? Look, let's come back to Mississippi airplane now. Why they use bicycle landing gear? Why they use this landing gear somewhere under the belly of airplane? First, they are going to hide it in the fuselage. Second, proportion of this airplane, the width span is so huge that if you even place landing gear immediately from sides of fuselage, at flight it's normal, no problem. But when taking off and landing, it will be like like drunken swan, do forgive me, like drunken broad, yeah, that one unbeautiful that we have seen. It will be practically unstable in this rolling direction, in roll axis. It will like falling down from side to side because landing gear is immediately practically in the middle. And they solved this problem like this. They placed bicycle nose landing gear main legs, which they may hide, big one, huge one, may hide in the fuselage, and they used additional legs of landing gear, tiny one with respect to this big main landing gears, easy hideable at the in the wing structure at the tips where they already have no fuel tank at least. And this decision, you see, first, why it's so high? Why it's so high? Why it's not? No, certainly here, no, it's already half retracted, but certainly here it's shorter. This airplane closer to the ground while takeoff. Why this thing is so high? One of reasons, it's not the only, but one of them, that they have huge props here. Do compare the size of fuselage, but look, cockpit, now you see, you understand that people here accommodated normally they may walk there in full height, and additionally it's under the cockpit the place. And do compare the size of prop, it's really huge. But moreover, it should be even bigger, greater in diameter in order to provide the necessary thrust. What they did, you see a trick with so-called coaxial prop. On one axis, they have two props and they rotate in different directions. Additional plus of this, besides of compactness of the size of the prop itself. What is the time it's normal yet. Additional advantage of this shortening compactness of the prop, that prop while rotating, it create the force torque moment. And it's like trying to, the third law of Newton, and if you have here torque moment which appear due to rotating of the prop, it means that it's trying to anti-rotate the plane. So it's affect the plane, trying to to break stability of the plane in another direction. And to solve this problem in airplanes which has big props, usually, no, it's practically not notable when we see it in airfield. But such airplanes, they have fin deviated to some angle, 3-4 degrees from vertical axis. Fin is not straight there, but a bit deviated to one of sides to counteract, to permanently counteract into this moment which props create, this reactive moment. And this case, when you have, it's called coaxial props, they are counteracting to each other with this moment, and they compensating this reactive moment. And in this case, fin may be directed immediately along the longitudinal axis. You understand this deviation of the fin? It's create additional force permanently, additional side force. But together with the additional side force, it create permanently additional drag. And due to this, it's spending more fuel time and so on. It's especially important, as I already said, for civil airplanes, of course, to save fuel. Anyway, such decisions are in the civil airplanes everywhere, and they are all over the world for these prop-like airplanes. People just force it to do it like this. And one problem with this landing gear, as I'm already said you, that they need space for props. That is why the whole airplane looks like long-legged. Yes, of course it's increase the weight of the main legs in this case. Of course it's overweight, as I'm already said you in this decision, but it's like there is no another way maybe for them. And why this engine do not use jet engines, for instance? Maybe strategic bomber, it may fly faster, yes, because they need fast speed. Because it's engine of that period of time when jet engines been yet not sufficient in the thrust. There were no enough capable, no enough powerful engines developed by the moment, and they've been forced to use turboprop with these coaxial wings and increase the length of the landing gear in this case. Look at this. I hope you are not tired yet. Look at this. What I said. In case you have no engines, no, the same two airplanes of the same age, of the same period of time. This one used for turboprops, because turboprops being in wide development, they existed by the moment when this airplane was developed. You should understand that time to time it's happened that engine developed exactly for the airplane, but in this case, more probably it's some derivation of airplane from previous, like family of airplanes, and this derivation it's no, derivative airplane. It's just airplane with another engine. Let it be maybe fuselage little bit extended, or some in wing structure maybe a bit changed, but practically the same airplane with another engine. That what does it mean? That engine being developed especially for this airplane. If airplane completely, like from zero, and concept created, and engine also for this airplane created completely from zero, it takes around 15 years altogether, even with appearance of powerful computers, with all our sophisticating and so on. Uh, it will be so long that in 15 years already no one needs this airplane, do forgive me, when you're ready to start manufacturing. And next it's preparing of manufacturing for some years also. Well, look at this. It's a Soviet airplane. They decided to use four powerful enough turboprops, but they lose in what? In altitude and in speed. In this case, you do remember that prop is limited. Uh, their competitors in everything then approximately the same period. They've been used jet engines, as you might see, jet engines, but do count how many. Uh, exactly as I said, maybe because more capable, more powerful engines not existed by that moment. You see, 8 engines, and they are placed by couples, one pylon, 2 engines, and they are placed like in front of the wing. And certainly conditions of downwashing, they are effective enough, let's say, and that is why they use conventional scheme of stabilizer. By the word, do pay attention how great stabilizer is. Maybe it's not, you see, it's not a B-52 Stratofortress. It's a very famous airplane at its time, and now it's also famous. And do pay attention either how many legs it has in landing gear. And seems like this landing gear, it has both left right leg in front and right left leg somewhere far under the bottom. Interesting decision also, yes, for landing gear. Also because it's very wide, let's say, span of this airplane is very wide. Comparatively to Tupolev, not if not another type of engine, we might say they fly with the same speed. But you see here is swept wing, and here is also swept wing with long aspect ratio and so on. But do pay attention that that one will have more no like extended limits with respect to Tupolev airplane because it has another type of engine. And once again, coming back to the story that I already said, look how big here stabilizer and fin area of fin and stabilizer both are really, they are great with respect to the area of the wing. It's to provide stability, yes, of course, but do remember that this conventional scheme of airplane, it's convenient for both designers, manufacturers, it's convenient. But in operating this conventional scheme, it's stealing the lift permanently because stabilizer direct lift in another side. Yes, maybe, but it's maybe not even true. Do forgive me. For instance, in our Ruslan, in our Maria, and no, about this I know for sure. Um, let me to draw my ugly pictures again. Airplane, approximately. And been talking at the beginning about balancing scheme of airplane and the reason of stabilizer at all, what it for. We've been talking that, let me to draw the wing is a hop and stabilizer of conventional scheme. Put somewhere here. We have Z1, Z1, Z1 will be broken right now, I trust. and Z1. Not so ugly as usual. And we need to make copy. And one more just in case. If I spoil two first of them. Let's see the possible forces. Gravity should be, we talked about, gravity should be closer to this side. Gravity center. Let's increase it. Center of gravity in front of lift center of pressure. What for? If you choose another scheme, center of gravity is here and lift is somewhere here, that one, left one, has tendency to pitch down, and in this case it's loose lift on the wing. It's pitching down, rotating in this case to position with nose down, and it means that it's reducing the angle of attack, and it means that it's reducing the lift and start gliding down. It's not rotating permanently with nose down. It's continue to fly, but it's gliding down, and you yet have time for making decision what to do. If no stabilizer, let's imagine we have no stabilizer. We have only two forces, couple of forces. That one, that dreadful one, do next. In case of any changing of relative wind, so-called, for instance, you have normal speed and some shear of the wind, some blowing to the nose. What happened? It's increase the lift and start кабрировать, pitch up. And that one is resulted automatically in appearing of increasing angle of attack, in appearing of additional lift. Additional lift increase once again angle of attack, additional lift, additional angle of attack, and it's finished up with stall. And very quickly, extremely quickly, this airplane rotates up and start spiral motion, very sharp spiral motion, like falling down and rolling simultaneously to the ground. Dreadful situation, practically no way to stop it. Look, this one I said, stable one, approximately stable one, conditionally stable one. That is certainly unstable one. Okay, now we add stabilizer. Stabilizer on the left one. On the far distance, little stabilizer, little. It's not necessary to have here much area, because if it's placed far, if arm with respect to the center of gravity is big, here is greater arm, less force. Here is less arm, greater force. No, you do remember those stories, I trust. And so it's equivalent moment from both of forces. What about in this case? How to compensate this pitching up moment with stabilizer? Look, stabilizer may direct the force up. It may direct force up, and in this case, it's improve the lift, both stabilizing their wing. But that is yet unstable scheme. It's a bit dangerous scheme anyway. And in this case, you may do more area of stabilizer, even on very big leg. It's maybe a rather big area of stabilizer in order to improve, like to increase lift, possible lift in the flight. Seems like that one is better, but that one is yet risking, dangerous variant. Will not explain it right now, but it's considered like unstable. but that unstable variant resulted in higher lift for the same weight of structure. Look, I have structurally the same airplane, no, seems like structurally it's the same, but weight here is it's compensated with not compensated, how to say it, weight here and weight here. It's here is lift minus some lift, and here is lift plus some lift on stabilizer. So quite clear that this wing may be less. If it's less, it's not heavier than no, it's not so heavy. No? The whole area, both wing and stabilizer, may be like common area, may be less in comparison to the left version. This airplane, yes, it's unstable. It's demand permanent tight controlling of the airplane, and it's considered like unbearable for human, such controlling of airplane. But it's quite normal for computer. And with appearing of fly-by-wire devices and with appearing of computer-driven, let's say, control system, this scheme became more popular. And as far as I know, the same scheme, like with lighter, which is finally resulted with lighter structure, less relative mass, relative weight of the structure will be with respect to normal conventional scheme with higher stability in flight. And this scheme is realized in our Antonov 124 and in our Antonov Mriya 224 airplane being realized with this wrong approach to stability, let's say. Let's come back to what we've been talking about. And as I'm already said, look, considering what big arm of what the big arm of stabilizer here, it's already create questions. Why it's so big, this stabilizer? Whether this scheme is stable or unstable, and what is also interesting, look, in this way, if in this, I mean, when the wing is with the lift force in front of center of gravity, center of gravity of the airplane itself, where wing may be with respect to the usual conventional scheme, when the wing is in the middle of airplane or even far to the end of airplane. I'm trying to show it, but like closer to the end of airplane might be in this case. In contrary to these decisions, usually unstable scheme of unstable balancing scheme seems like quite conventional in appearance, but typically in this case, wing is closer to the nose of fuselage. It will be more, more efficient in this case if you place wing closer to the nose. And if we pay attention to those photos, look, it's practically on the nose of the fuselage. Maybe it's also realized this unstable, conditionally unstable balancing scheme when center of gravity is far than center of pressure of the wing itself, and that is why they have big stabilizers and so on. Maybe not. Maybe I'm wrong. It's only my like preposition. I think like this. Because this information, you understand, no one reveals such information. If only some spies steal the drawings, manuals, and so on, then it's possible to make some conclusion for sure. What do we see right now? And I'd like you to start remembering the names already. Some names I have pronounced today, and mostly they were names either of our famous design bureau or of American European design bureau. That one That is, no, Scaled Composites, it's a company been working with such airplanes. The weirdest creature, maybe, that we have seen for today class yet, but not the last weird creature. And do pay attention to this airplane. What is it? It has fuselage. It has couple of beams for placing the fin, and fin is directed top, directed bottom. You see, uh, it's so-called tandem wing. In this case, it's the wing itself. Do forgive me. Insufficient with respect to the fuselage. We're watching this wing and think, is it really fly? This dragonfly? Yes, it's really fly, and no, yes, somehow remind the dragonfly. In case this fore wing much shorter, we might say it's canard scheme, because no, it looks like canard scheme. At the fore wing, it's high plane. Pay attention. At the half no back wing, it's middle plane. Look at the fuselage. Look what happened with the fuselage. Dragonfly, no? Head is heavier than body itself. Fuselage, it's not straight. It's not typical for passenger airplane. Fuselage or for military airplane, it looks rather weird. Look where they're going to hide the, why they have this, they combine decision of displacing the fin. They may extend fuselage here and place fin here to make quite convenient empennage. Yes, but what they have decided, they place it in the back wing. They place it couple of nacelles, which are looks like beams for holding the fins, but really what they are used for, you see, no, they have doublet purpose. They used for hiding the, for retracting the landing gear main legs, and they are also carriers of fins. Look at the wing. No, it's not even gull wing. It's something. It's broken closer to the tip, and this also remind. I have already shown you today as wing. And let me to show you one more. Oh, this one. This I'm already mentioned this bird, albatross. Let me to find it in English. How it's called? Да. Called quite the same, albatross, and maybe pronunciation a little bit different, of course. No, albatross, and this creature, you see, it has wings like a bit broken. While gliding, their wings, it's a bit broken. If you open already the movie that I sent once a couple of days ago, oh, how many you have here? To find something, it's little disaster movie, and that was movie about what that one? How Airbus going to no, what they going to replace the one of the popular airplanes, and here is the story about prop fan engine or open fan on or whatever they call it, and they also going to change the shape of the wing and going to change it exactly in this shape, in albatross shape. What is the reason for this might be? I already said you aerodynamical quality of modern, very well, not here. Modern airplanes, aerodynamical quality of passenger cargo modern airplanes, no, 8, 10, 12, let it be. Not much. For military airplanes, it's around something like from 12 to 20, let it be. No, 15, 18, it's quite normal for maneuverable airplanes like fighter attack airplanes. And when it comes about the aerobatic airplanes, it's maybe between 20 and 25. No, for aerobatic and for some of the best gliders, aerodynamical qualities is very high. It's around 20. What does it mean, aerodynamical quality? Great lift and very little drag. High aerodynamical quality resulted in high lift, low drag. Great thing, of course, for gliding, great for saving the fuel, but not great for maneuvers, typically. So military airplanes not even strive to increase their aerodynamical quality, compromising with their maneuverability at the same time. And no, at least they do not try to elongate the wing to make higher wing aspect ratio. What about this airplane? This is not a real airplane for transportation of something or for such airplanes. They are so-called experimental planes in like flying models in real to check some strategies, to check some concepts. Of course, it's very expensive way to study something. As we have wind tunnels, for instance, we have now we have ability of computers to use computational models, and fluid dynamics has now computational means, not only methods, but means for quick, rather quick, it takes some days, such computations, or couple of weeks. In contrary to the 20, 30 years ago, when the same computations may been done for ages, for some weeks or for some months, one case of computation. It's like you clicking the mouse and waiting for 3 days until window is appeared. No, quite clear that capacity of computers that was insufficient for such computations. And even now, when we have developed computational fluid dynamics and powerful computers, anyway, we still force it because it's too much responsible. Some things may be simulated in computer, but after this, at least some general control points must be checked in natural tests, in natural experiments. And such airplanes, they are mostly for these purposes. They experimental concept or airplanes which by their flight, they study some aerodynamical phenomena, they study some regimes of flight, no, and so on. No, that one may be characterized like we have already said by aerodynamical scheme. Tandem, fuselage with two beams. These beams are used for hiding, retracting the landing gear. Twin fin, stabilizer, quite clear it's not necessary. What it's maybe used for, I trust, considering this underbelly device, maybe it's also may used for reconnaissance, such a thing. And it's rather speedy, but not supersonic. This idiotic shape can't be supersonic, I trust. It's only subsonic. And it has couple of engines. It's visible on sides of fuselage, higher than fuselage on pylons, higher than fuselage. It has couple of jet engines, not turbofan, but simple turbojet. No, and about weird things, let's continue. Do we have time yet to entertain you? Yes, no, literally 10 minutes and we will stop. Because maybe about those people whose airplanes we see right now, we will have like, to talk separately. I'd like you make acquainted with these people. Just it's not possible to give you information about all the tendencies during the 100 no 101 half of years already, like 150 years the age of aviation. Not quite like this. When it comes about airplanes, it's only 122 yet. But if we start counting from Можайский airplane, it will be already 150, of course, certainly. And before appearing of airplanes, people already fly on gliders and fly on flying balloons. So aviation age, not aviation age maybe in means of transportation of cargo and people, but in means of human flight, it started much longer ago than 150 years already. Funny creature. Uh, Again, no, not dragonfly like it was here with its tiny, delicate shapes, whatever weird they are, but they are rather tiny, delicate. This one looks more convenient, no, more conventional, in our opinion, yes. But look again, what is it? Above the wall, no, tandem wing. Tandem wing. Here is the probe, as you might see, inlet holes for the engine, for these nostrils. Insufficient, maybe it's a piston engine inside, and we not see no insufficient intakes, I mean, and not so great like for turboprop, and we not see where the exhaust of this engine is, no, where the significant exhaust like it was in, no, not like here, yeah, you see, in this airplane we not see exhaust hole significant, and maybe it comes about the piston engine in this case, prop with piston engine, and of course this engine placed it somewhere here in the mid, no, in the fore fuselage. Cockpit is over, no, practically a bit over protruding from fuselage, not visible here. Pay attention to the wing, scheme of wing. Is it conventional? No, it's tandem. And this tandem, you see low wing at the at the fore wing, and on the back wing, it's high wing. No, certainly it's for convenience of pilot. Above the all, the pilot may conveniently take into the cockpit. Uh, yeah, by the way, it's not for transportation of people or something like this. It seems like it's for the only pilot. And that one has landing gear. Where the landing gear is and what's the scheme of landing gear. That Proteus airplane, it has quite common landing gear. Not common decision to hide it, where to hide it, but it's quite common. Three legs, two main legs and nose wheel leg. Look at this. Two main legs and where they are. Here, it's not retractable really. What it's seen like wing tips, they are really callings for landing gear. And where's the third one? Here. So this airplane, this one, its airplane name, look, easy to remember, but not for me, certainly. Uh, and this model is developed and constructed, no, it's constructed with the same income collaboration with the same companies that previous airplane scale composites, Bert Rutan. In English, it's pronounced Bert Rutan. This person I'd like you to remember, and I hope we will opportunity to talk about him a bit and about his structures later. And I'll show you some more airplanes of Bert Rutan and some more planes of another person. For you, maybe it sounds similar. Bert Rutan, Rutan, it's a family name. And Bartini, Robert Bartini. Somehow it's intertwining maybe in your mind now. Bert Rutan is modern designer, modern American designer. Rutan, family name. And Bartini, he was Soviet designer, but he was Italian. How it happened that Italian man went to Soviet Union and became extremely important, famous designer, but he was unknown practically to society. Like he was secret person at that moment. How it's happened and what his works are, we will talk later. Right now, I just ask you to remember these names, Bert Rutan and Robert Bartini. And let's take a look, practically, a look to the structures, and let's stop on this. What do you see? Fuselage, pay attention. Also broken in the belly. It's like pull it down on the aft fuselage. And here is one of Bartini work. It wasn't finished. It wasn't finished finally by Bartini. It was finished next after Bartini died. It was finished with another designer. That is already more weird, and that one developed for military purposes, and it contains a lot of aerodynamical and technical decisions which are pioneer, revolutionary for that age. It's middle of 60s of 70s years approximately, like the late age of Soviet Union. And you see here is central fuselage. On side, some additional like sub fuselages on that side also. Extremely insufficient wing. How this creature may fly with such a wing, seems like. But if you recollect about story about the screen planes, so-called, that I talked to you once already, no, at least some words I said. It's example, those things, they are examples of screen planes. And one more screen plane, what here is real screen plane, amphibious plane, ekrana planes, actually they are called. They may have different, a bit different appearance, but their idea that they use fuselage blended with the wing, usually like blended body, and they are flying not high. They flying they most effectively near the ground due to ground effect. Also, not right now. But here is the work of Bartini, works, different works of Bartini. Take a look. Some of them been realized in full scale, and they been in used. Some of them now they the lasts of them in different museums, but they been in used really. The works of Bartini. Bartini is beginning of 20th century, and Rutan work. He yet alive. He is of the same age as we are. No, not age, the same period. And Rutan, American designer who's still alive, and he's working yet, but he's already in the age of around 70 by now, of course. What his work. What may be the purpose of this airplane? How do you think? To pay attention. Fuselage, the beam of fuselage, engines, asymmetrical fuselages, and asymmetrical position of props of engines. But it's not enough. Look at this. This wing, it's so-called oblique wing. It's not along the same line. You see? Pay attention to the tail unit group, empennage. Two fins on two beams, or fuselage and beam. But stabilizer into one side, it's disappeared. It's not stabilizer here portion. And not the weirdest. Look at this. But typical for Dort Rutan to develop something like this. Similar thing we have seen that Proteus airplane, да? What also interesting decision, technical. And no, of course, in your case, you will have no such dreadful structures to analyze. You will have more convenient in your practical class. Well, once again, I remind you what to pay attention to. Purpose. No, your prediction about purpose. Military, civil, and in case it's civil, what it might use for. Additionally, pay attention to the type of the fuselage, whether it's conventional airplane or it's amphibious maybe, or hydroplane, if you have such a photo, flying boat, so-called. Amount and position of wings, type of engines, amount and position of tail unit group. It's not compulsory, it's the tail, as you might understand now. Make preposition about some provision about the possible range of flight, whether they are purposed for the supersonic flight, for subsonic flight, or for the low subsonic flight. For instance, look at this. This airplane, it has much more thin, delicate shapes, sharp shapes, and it has type of engine, jet engine. And that one, it has prop engine, whatever this engine is. No, I trust it's turboprop, so it's not piston, it's turboprop. But certainly that one is more slow in range speed and in cruise speed, and that is more speedy in cruise speed. But more probably it's not supersonic yet. Yes, it's no, for supersonic it's too long on sides. And look what is it may be used for. Something that we might understood as additional fuselage here. This something maybe is the carrier of another vehicle. Look at this. You see. No, well, let's stop on this. Once again, your task is to recognize types of airplanes on one hand, up to 5 points for some photos, and you are writing down this, yes, either immediately in the picture or under the picture. And second half of task is to recognize flight controls. No, repeat together quickly with you. Oi, not that file with your tasks will be what might be variants of flight flight controls. Very beautiful picture. Primary flight controls are elevators, rudder, and ailerons on sides. High lift devices, flaps. Here might be sleds, spoilers, interceptors, maybe some air brakes. I haven't found anything with the air brakes yet, and in other devices. And as to the wing, picture photo will be similar, but I'm afraid completely not complex, because practically in all the photos you will see the same features: flaps, ailerons, wingtips, and sleds somewhere visible. And your task is to recognize and to give name and to explain their functions in terms of flight. On this we will finish. Actually, it should be shorter in order you might do some some tasks that you are doing individually, and next we are checking. Considering our circumstances, let's spend now at least all this time for our conversation, for my talking to you. And after this, we will stop, and I will download files with tasks in Mentor. And in case you have no access in Mentor, maybe I'll double it into TikTok. You will see. Let's meet again in TikTok about these tasks. And right now, we will stop the record.